Hello everyone, welcome to our unit on probability distributions, and random variables. If you're new here, I'm Goldie and I'm here to make AP statistics easy for you. Today we're going to be going through notes to the addition rule, where we are going to be covering mutually exclusive events as well as independent events and union of events. This is going to be an exciting addition to our content knowledge on probability. So grab your notes, get settled in, and let's go through this content together. And before we get into what the addition rule is, we're going to talk about a special type of occurrence called mutually exclusive events. Mutually exclusive events happen when two events have no outcomes in common. Meaning that they cannot occur together. So I have two bullet points here. It says the probability of A and B and the probability of A or B. And this idea of and or is present in all throughout math and in computer science as well. So if you've taken a computer science course, this might sound a little familiar. But just in case you haven't been exposed to the difference between and or yet, in math, and means that it happens at the same time. So when we talk about two events happening together, A and B, it means they're happening at the same time. Now, with mutually exclusive events, the probability of two events happening at the same time is going to be 0, meaning they cannot occur at the same time. An example of this would be if I rolled a dice. The probability that I roll a 6 and roll a 4. What's that probability? What's the probability that I roll a dice and I get a 6 and a 4? Well, that's 0, right? I can't get a 6 and a 4 when I roll a dice. I only get one number. So these two events occurring together cannot happen. So we say the probability that A and B happens is equal to 0. And that's mutually exclusive events. A or B. The keyword or means that either event occurs or that they both occur. Okay, so we say either or. So the probability that A occurs or B occurs means that the probability A occurs or B occurs. Okay, not at the same time necessarily, but either or. So let me put that in some plain English here. The probability that I roll a 6 or roll a 4. Okay, how do I figure out that probability? Well, we just said how they can't occur at the same time, but we can have one or the other. And to find that probability, what we're going to do is just add up the individual probabilities together. So the probability that I roll a 6 is 1 out of 6. The probability that I roll a 4 is 1 out of 6 as well. So those probabilities together are going to give me 0.333. So I added up their individual probabilities in order to get their combined probabilities. So the formula for this probability of A or B is the probability of A plus the probability of B. And we're still in the realm of mutually exclusive events. That's what this whole first page is going to be about. So two events that cannot occur together. In this example here, we're going to revisit our rolling 2 dice game, which is what we did in the intro activity. If you didn't do the intro activity, that's fine. It's pretty easy to pick up on. You just roll 2 dice, right? Roll 2 dice at the same time and then record the sum of those 2 dice, right? So if you roll a 1 and a 1, you get a sum of 2. Etc., etc. And that's what the table is going to show here. So I have 2 events. A is going to be rolling a sum of 5, and B is going to be rolling 2 even numbers. So those are my 2 separate events. First question, are these events mutually exclusive? If you're asked a question if events are mutually exclusive, you have to look and see, do those 2 things happen at the same time? So rolling a sum of 5, I get a sum of 5 here in these 4 occurrences. That is where I get a sum of 5. where I roll two even numbers, I'm going to do a different color here. Two even numbers would be 2 and 2, 2 and 4, 2 and 6, 4 and 2, 4 and 4, 4 and 6, 2 and 6, 4 and 6, 6 and 6. Okay. So I can see those two events, I have them circled. Do they overlap? Can you roll a sum of 5 and roll two even numbers? No. Okay. They are not mutually exclusive. Or excuse me, you can't. They are mutually exclusive because they can't happen together. Ooh, I almost got turned around there. They are mutually exclusive because they have no events in common. Okay. So yes, mutually exclusive because they have no events in common. So the probability of A occurring, the probability of rolling a sum of 5, there's 4 out of a possible 36 where you can roll a sum of 5. The probability of B, rolling two even numbers, we circled all of those. There were 9 outcomes out of the 36 where you could roll two even numbers. Now the probability of A or B, because these are two mutually exclusive events, you're just going to add up those individual probabilities together. So 4 out of 36 plus 9 out of 36 to give you 13 out of 36, or in decimal form, 0.361. Okay. For our second example here, we're just going to identify if the following events are mutually exclusive. And if they're not, give an example of where they overlap. So we're still doing our rolling two dice. So for example, A, rolling a sum of 4 and rolling doubles. Okay. Are they mutually exclusive? Well, can you roll a sum of 4 and roll doubles? Okay. Well, you can. Therefore, they are not, I'll just do not ME for short. You can roll a 2 and a 2. If you roll two 2s, you get a sum of 4, and you also just roll doubles. So because those things can happen at the same time, they are not mutually exclusive. Okay. I'm going to go ahead and let you guys try the next 3 problems. Pause the video, do the 3 problems, and press play again when you are ready to see the answers appear. Okay, here are your answers for B, C, and D. Take a look at them. Again, pause the video if you want to see and copy down those answers to double check, but hopefully you got those correct. Okay, so that shows us how we find probabilities of mutually exclusive events occurring together or occurring, either or. Now, what happens when they're not mutually exclusive, like some of these examples that we had here? When they're not mutually exclusive, what do we do? Okay. That brings us to our third example. Find the probability of rolling doubles or a sum of 6. So we have 2 events. We have the event where we roll doubles, and we have the event where we roll a sum of 6. Okay. So I'm going to highlight in blue here, rolling doubles. Okay, so doubles would be 2 1s, 2 2s, 2 3s, 2 4s, 2 5s, and 2 6s. Okay. And I'm going to do red as rolling a sum of 6. Okay. Rolling a sum of 6 occurs here, 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 and here. Okay. So now I can see all of a sudden I have some overlap. Okay. I have an overlap right there where I roll a 3 and a 3. Rolling a 3 and a 3 is rolling doubles as well as rolling a sum of 6, which means that these 2 events are not mutually exclusive because you can roll a 3 and a 3. That's their overlap. So let's take a look at their individual probabilities first. The probability of A of rolling doubles, there's 6 events out of 36 where you can roll doubles. Okay. The probability of B, rolling a sum of 6, there's 5 out of 36 events where you roll a sum of 6. Now, what's the probability that they occur together? Well, where they occur together, there's only one event where they occur together. So the probability of A and B, there's only one event out of 36 where they occur together. Okay, so this is the probability they occur together. Now the probability of A or B. So when they were mutually exclusive, we just added up their individual probabilities. Okay? So let's see what happens if we do that here. We have 6 out of 36 plus 5 out of 36. If I add them both together, I get 11. Okay? Now, if I look at my board here, I can see how many of these events have rolling doubles or rolling a sum of 6. Okay, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 events total. I do not want to count that event twice. Okay, rolling a 3 and a 3, I don't want to count it twice because it is a single event. Okay. So what happens when I add the 6 out of 36 plus the 5 out of 36, I count the overlap twice. So what I'm going to do to not count the overlap twice, I'm going to subtract the overlap. I'm going to subtract that 1 out of 36, subtract the overlap, and that's going to give me 10 out of 36 as my probability of rolling doubles or a sum of 6. And just to put that as a decimal, 0.278. Okay. And that's what this little italicized note says down here. When we have events that quote unquote overlap, adding their individual probabilities will count that overlap twice. Okay. So we have to subtract one of that overlaps so it only gets counted once. That idea is called the addition rule, okay, or the general addition rule. If A and B are any two events resulting from a chance process, the probability of A or B occurring is equal to the probability of A plus the probability of B, but we have to subtract the overlap minus the probability of A and B. That is your general addition rule. But just notice that if A and B are mutually exclusive, the probability they occur together is 0. And this formula gets us back to the formula we talked about on our first page. Okay, so it checks out for mutually exclusive events. Okay. So we can find their individual probabilities. How do we find the probability that they occur together? Okay. Well, in the problem we just did, we used common sense, right? There was 1 out of 36 possibilities where they occur together. And that's what we'll do to find that overlap for right now, where they occur together. We do have the general multiplication rule that we can use to find that overlap later. So we'll learn about that a little bit later. For right now, like I said, we'll just do some common sense work. Here's a deck of cards laid out for you so that you remember what a deck of cards looks like. You're going to select a card at random from this deck. There's 52 cards total. Okay. You're going to determine if the following events on the next page are mutually exclusive, and then whether they are or not, you're going to find the probability of these events. So let's do the first one together here, the probability of a red or a queen. So when you're asked the probability of or, know that you are doing the probability of red plus the probability of a queen minus the probability of a red and a queen. It's going to do Q for short. Okay. The general addition rule works for all events, whether they are mutually exclusive or not mutually exclusive. Okay. Where it comes in is if you're trying to find a red and a queen. So do we have a red and a queen? We do. Okay. We have 2 cards that are both red and a queen. So because we have 2 out of 52 cards that are both red and a queen, these are not mutually exclusive events. Okay. Okay, so they wanted us to identify if they are mutually exclusive or not. They are not mutually exclusive because you have those two. Probability of a red, half the deck is red and half the deck is black. So red, the probability of a red, there's 26, half of 52 is 26. I like to keep them all the same denominator, so I'm going to write 26 out of 52 instead of 1/2. And then the probability of a queen. How many queens are there in the deck? There are 4 queens in a deck. So you can see, based on my circling, how we managed to count the overlap twice when I added up the probability of a red plus the probability of a queen. If I add all of these, if I add those together and then subtract the 2, I get 28 out of 52, which is going to be 0.538 as the probability that I pull a red or a queen from my deck of cards. Okay. Go ahead and pause the video and try B, C, and D on your own. Press play when you're ready to see the answers appear on the screen. Okay, here are your answers for B, C, and D. For B, they were mutually exclusive. You cannot have an ace and a king. So you just added up the probability of picking an ace and picking a king. Okay, or picking an ace or picking a king. Add them together. For queen or an even number, those are mutually exclusive. Just to clarify, even numbers would be your 2s, 4s, 6, 8s, and 10s. Okay. Different card games have face cards and aces being different values. So when we talk about an even number or an odd number, we are talking about what is actually present on the card. So you see there are 20 even numbered cards there. Okay, so that's why we have 20 even cards, mutually exclusive, so there's no overlap. And we have our probabilities. Same thing with the black or odd. They are not mutually exclusive. So we have the probability of a black card plus the probability of an odd card minus 8 of the cards are going to be black and odd. Okay. Our last example for the day is based on a two-way table. Okay. So you wanted to know how many students at your school ate breakfast regularly. So you conducted a survey, asked a question, 600 students in your sample, and the results are shown below. So if we select a student at random from the 600, what is the probability that the student is? And then we have our 4 questions here. What is the probability that they are a female? So a female means that we are taking our 278 females in our school, dividing by 600. Okay, so the probability that you randomly choose a female, 0.463. Okay. So you use that total roll when you want to just know one of the variables. So here we were just interested in the variable female. Okay. In the gender variable, we were just interested in female. Didn't matter if they ate breakfast or not. Someone who eats breakfast regularly. So again, part B, we are just asking for breakfast regularly. Okay. So total, there were 300 people who eat breakfast regularly out of 600. And that is just such a pretty little probability there, 0.5. Female and eats breakfast regularly. Okay. So the and is the key for part C, where they occur together. So female and eats breakfast regularly, that is going to be 110 out of the total of 600. Okay. Randomly selecting a student. So all of the students, all 600 is your sample space, that they have these 2 characteristics. There's 110 of them. So that's going to be 0.183. And now we see the keyword or. Okay. Female or eats breakfast regularly. Whenever you see that or, remember your general addition rule. Okay. You have to find the probability that you have a female, okay, plus the probability that they eat breakfast. I'm just going to say eat, minus the probability that they are female and eat breakfast regularly. Okay. So we actually already figured out all 3 of those in the previous problems. We had 278 total females, and we had 300 total people who ate breakfast regularly. In each of those, we have female and eat breakfast regularly, so we don't want to count it twice, so we subtract the overlap where they occur together. And that's going to give us 468 out of 600, which is 0.78. You could have also done this with the decimals as well. That would have been totally fine, but I wanted to use the fractions here. Okay, so big difference here, big takeaway. Know the difference between and or. Okay, and is where they occur together, or is where either or both occur. Okay? We subtract the overlap because we count it twice. Okay? That's where that general addition rule comes from.
And that wraps up our lesson on notes to the addition rule. Thank you guys so much for following along. If you have enjoyed this video, please hit the like button and subscribe to my YouTube channel for more great AP statistics content. And until the next video, I wish you endless statistical success, and I will see you then.